Okay, so we're going to work with summation notation. Okay, we're going to look at the very first example, and we're going to try to write this as a form of sigma, and then we'll go into the second one, which is a little more difficult of a question. Now, summation notation deals with this Greek letter sigma, and usually they have it written as the value on top, so maybe you'd call it n, and then I equals some value. Let's say we're starting at maybe 0, and this equation is the value I. So in other words, this can be written out, okay, as something like n being endless amount of numbers. Okay, so an example of that could be, let's say in this case, we're gonna stop at the number 10. Okay, we're gonna stop at the number 10. And what it's saying is we're going to find the sum of all the values, that's what the sigma is, from when I starts at 0 all the way up to when it ends at the number 10. So in order to really do this the long way, we would have I being 0. That would be our first number. And then we add up, because it's a summation, 1 plus 2 plus all the way to the value of 10. Okay, so this is our summation of the letter I, all the way to number 10, and this is where all of our addition comes from. So in this question, they've given us the value t. Okay, so we don't actually know what this value is, but we know it's, think of it maybe like term, and this is the first term plus the second term plus terms all the way up to the value of 12. So in summation notation, we have our sigma. Well, what is the last value or last term we go up to? 10. In the example.
Example 12.
12, that's right. So it goes all the way up using natural numbers up to 12. Okay, and we know essentially our equation is t, and we could write it as I or k, whatever our variable is we'd like to have. So let's go t at I, let's say. Okay, and what it is I, in this case, starts at what value?
1.
That's right, when I is equal to 1. So in other words, we start at the value 1, so we take term 1, and we're going to be adding to term 2 plus term 3 all the way up to term, 12, that was subconscious, T12, okay? So that's how we could sum up our very first one, A, okay? Now, the second one, B, is a little more difficult. Let's try to see if we can pick out what our differences are, and we'll do this one in purple. We know it's going to be a summation, okay? Now let's take a look at this. Looks like we start at 0. We have a combination of 9, combination 0 here. And then the next one, we go up to 1. So already we can tell that the first term is changing. It goes from 0 to 1 to 2. And it looks like it's going to stop at the value of 9. Okay, so we have a good indication that 9 might be our high value, but let's take a look at what our combination is also doing. Well, our combination, the first term in all of our combinations happens to be the number 9. So that's not changing. Okay, so that's going to be part of the equation right off the bat. We know we're going to have our combination, and it's going to definitely have 9 involved in it. That value is not going to change. But the second number in our combination goes from 0, 1, 2, all the way up to the value of 9. So that's changing along with our very first term. Okay, so we know 9 is definitely going to be the high number here. So summation of all numbers up to 9. Now this value, we don't know what it is, so we can represent it as letter I, we can represent it as k, whatever we want, right? So since we've been using I, let's just say it's the letter I times the combination. But what else changes in our combination?
The number of
that second number, right? And it changes. It changes by the exact number that this changes as, right? And we've called that we've called that I. Okay. So in other words, our second number down here is going to be combination 9 combination I. Okay. And we know that our starting value for I is what?
0.
So when I is equal to 0. So when I is equal to 0, we're going to sum up all the terms from 0 to 9. And our equation is I multiplied by the combination 9, or 9 combination I. So it's going to change as we go through it. Okay? Does that kind of make sense?
Yeah.
Okay, so let's try a couple of the other questions there. Okay, here's another one with summation notation. Okay, this one again kind of tricky. It looks like we're dealing with fractions, correct? Okay. But what we want to really focus on is what pattern there is. We've noticed that our numerators, the numbers on top, are all increasing by the value of 1, right? And it just so happens the numbers on the bottom, the denominators, are also increasing by 1. The only difference is their starting points are a little different. In fact, the denominator is essentially plus 1 of whatever the numerator is. Okay? Well, we could definitely write our summation, because we know we're going to add these all together, as a fraction. Okay? And what we're going to do is I'm going to choose either the numerators or the denominators to be my imaginary number or my unknown. Okay? So let's call the unknown number, we'll call it n in this case. For instance, if I put n as the numerator, actually that's what we'll do. We'll have the numerator and then we'll do an example where we'll call d our unknown number, the denominator on the bottom. So if n is our numerator, well, we know our numerator starts at what value?
2.
2. So we know n is going to be equal to 2 to start. And what does it end at?
7.
7. Great. Well, we know our numbers on top work perfectly. We go from 2 all the way to 7. But what about our number on the bottom? How much higher than our numerator is the number on the bottom?
1.
1. And it's always that case. So in other words, we're going to write the bottom as n plus 1. And we could have done this as a denominator also. Let's say we decided, okay, we'll call it d this time. We know it's going to be a fraction. Well, our denominator is going to be the number on the bottom, our value, and d is going to start at what value?
3.
3. So our d equals 3. What does it go all the way up to?
8.
That's right. Our number on top is related to d how?
D minus 1.
That's right. That's d minus 1. Both of these are acceptable summations of what we just done above.